All right, let's look at the inverse hyperbolic functions. All right, so inverse hyperbolic functions are defined exactly the same way as we have been defining inverse functions. Say y equals f inverse of x if and only if f of y equals x. So inverse function is just a reverse process of the original function. All right, so inverse hyperbolic sine function is defined as sine of hyperbolic sine of y equals x, and the same way with the inverse hyperbolic cosine and the inverse hyperbolic tangent. And the only thing you have to worry a little bit about is the inverse hyperbolic cosine. But if you remember, the hyperbolic cosine looks like this. All right, and you can see that this graph does not pass the horizontal line test, which means that this is not one-to-one. So if you remember, in order to have inverse function, it has to be a one-to-one function, right? So we have to actually chop the half of the graph off so it becomes one-to-one. So we typically choose the right half. So it's going to look like this, right? So this is so we're going to focus on just portion of the hyperbolic cosine function and find the its inverse function. And you can see that it's going to look kind of like this, right? So which is the graph here. All right, so this is the graph of inverse hyperbolic cosine function. And inverse hyperbolic tangent function, there's no problem because the original hyperbolic tangent function is one-to-one. So there's no complication there. All right, so those are the graph. All right, but other than that, it's pretty much the same, for any inverse functions. The domain and range are flipped, and also the graph of inverse function is symmetric about the y equals x, as we saw in general inverse functions. All right, that's it. I hope that this was clear.